So we're going to use our property of exponents and kind of think about that zero power we always know is 1. Negative exponents are what? What do we know about a negative exponent, everybody? Negative exponent means reciprocal. So please make sure you write that down, reciprocal. So it doesn't matter if it's in the denominator, we move it to the numerator, or numerator to denominator. In this first one, it says 4 to the 5th raised to the 2nd power. How many 4 to the 5th should I have?
2.
I should have 4 to the 5th times 4 to the 5th. And I wouldn't necessarily have to put this in a parenthesis. I could have written it this way, 4 to the 5th times 4 to the 5th. And if we are looking at that, our rule from a couple days ago said that when we have the same base, we keep the base and we add the exponents. So this is going to give us 4 to the 10th. Well, we don't always want to write it out even as just 4 to the 5th times 4 to the 5th. So we want to try and think, is there something we could do with 5 and 2 that's going to give us 10 when we take a power to a power? So if we were looking at that, what's going to happen is if we are taking a power to a power, and some of you might be thinking, what are we doing with 5 and 2 to get 10? Besides adding 5 plus 5, what else could you do with 5 and 2? We're going to multiply. So we're going to multiply the two exponents when we have a power, please write this, to a power. So when we have something like 3 to the 2nd, and it's raised to the 3rd power, that means 3, and then 2 times 3, or 3 to the 6th power. So as we are looking, powers raised to a power. So 4n to the 7th. What we are really thinking about, if we simplified it, is we are taking n, and we are taking 4 times 7. And 4 times 7 gives us 28. So this is going to give us n to the 28th if we are looking at that. This next one. If I am looking at the problem, I should have, Ashley, 4. What are we doing with our exponents? 2 times 3. And again, if you like to put it in a parenthesis, and some of you might be able to start skipping this one. And Jordan, I'm going to end up with 4 to the 6th. Most common mistake, I'll have people tell me this is going to be a 16. You got to keep the base the same. Patrick, as we're looking at that next one, we're going to have w to the 4 times 5, which Sam gives us w to the, what'd you get? We're multiplying w to the 20. So when I'm looking at your homework, is it possible that you go from this first step to here when they're pretty simple like this? Yes, I would be okay with that. As you look at that next page in your notes, we start adding a few more things as you are looking at these, so you got to be a little careful as you are doing this. So you just want to break each one down. So when we are looking at this, we want to write this first down below as x to the 2nd times, Luden, x to what power when we have a power to a power? So I'm going to take 6 times negative 4, which gives us negative 24. So I have x to the 2nd and x to the negative 24. So next, Cameron, I am going to be looking at it as I multiply these. I have the same base. What should I do with my exponents of 2 and negative 24? Careful. Here we multiply. On our assignment that we were doing last week and the beginning of this week, we want to take 2 and we want to now add negative 24. So please write it down just like this in your notes. Some of you aren't writing. Put down the 2 plus negative 24. So here we are multiplying when you take a power to a power. But when you have the same base, you need to add those. Okay? So you should have x to the 2 plus negative 24, which, Riley, when I add those together, is going to give me x to the negative 22. But Levi, we said at the beginning of the lesson that we can't have negative exponents. That this answer, what do we have to do anytime we have a negative exponent? Reciprocal. So what would my final answer to this problem be?
1 over x to the 22nd.
Yes, and now it is going to become a positive 22nd when we move it from the denominator, or from the numerator to the denominator as we are taking a look. All right, so Caitlin, we're going to look at this next one. We have a power to a power first. So what do I have to do with these two exponents first? I'm going to multiply. That's going to leave me with t to what power? -4. So Nolan, you missed the first part, but we are going to be multiplying our exponents here. So if I'm multiplying those, I'm going to have t to what power? -10. So, Aaron, we are now adding our exponents, so we're going to write it down as -4 plus -10 as we're doing our work, just to show. So that then when we are looking at our answer, so we're not making mistakes, Aaron, what'd you end up with? T to the -14. Joe, we can't have a negative exponent, so my final answer as I'm looking at it is going to be 1 over t to the 14. So if it helps you to put this one over 1 anytime, especially when we have those negative exponents, we're going to do it in that way. You're going to see when we take our quiz, which because of the musical Friday, we're going to have our quiz on Monday. But when you're going to see a problem like this, then I'm going to say, was the problem solved correctly? If not, what is the correct answer? So I'm going to ask you, what did they do wrong? How do we find their answer? What did we do? So as we look at this. So they had m to the second, n to the 3 raised to the 2, and p to the -2. So in that first step, Max, what'd they do? How'd they do different from here to here? What's different? And put what? N to the 5?
Yeah.
Should n be changed to the 5? So when we go to correct this, so we want to correct it, so the mistake started right here, right? So if I was doing that, we are going to write this as our mistake. We're going to write it as m to the second. And then what would we have now? N to what power? So I have 3 times 2, right? So I could put m to the n to the... Yeah, we're going to multiply n to the 6. And we still have p to the -2, right? Rajad, help us out. What are we going to do next? Are these the same base? No. So this whole deal where they even combine these together, we can't do that. So my hint is a lot of times negative exponents, circle, right? Why circle? That's what you have to move. That's the only thing you're moving is the negative exponent. So Rajad, my final answer should be, yep. Yes. So their mistake here was when they were looking at this, these were not both to the second power. We can't do that. So following the rules, multiplying first when we had that 3 times 2, okay? And the first thing that we want to take a look at as we are writing this is we want to think of 4f to the second should be written how many times?
2 times.
What is this? It's telling us the 3. So please write 4f to the second times 4f to the second times 4f to the second. Once we have written it in that form, Abby, we want to rewrite and put all of our number coefficients first. So if I'm going to put all my numbers, what am I multiplying for my numbers? 4 times 4 times 4 times 4. Then, Daniel, I need to put my variables, so I'm going to have what? Okay. So Daniel, when we multiply, we get 4 times 4 times 4. If we're going to leave it as a power, we could have it as 4 to the 3rd, but 4 to the 3rd is equal to what? 4 times 4, 16, times another 4. Remember it from the beginning of the year? 64. So this next part, if we are looking, Rowan, what are we doing with our exponents when we multiply and have the same base?
3f to 6.
Okay, because we are adding the 2 plus the 2, right, plus the 2. We are adding all of those together so that we get f to the 6, okay? So, keeping in mind our rules, when you multiply and you have the same base, you add the exponents. So now they're saying, well, what could we do for a shortcut here? So I want you to put back here, we're going to look at our shortcut. The shortcut would be, if we were looking at this, we are going to take 4 to the 3rd power. Remember, this is 4 to the 1. And we are going to take f, and we had 2 times 3. That is a much shorter way of writing, getting down to 4 to the third and f to the sixth to get this solution than writing it out so many times. So we don't want to be always writing it out. So that as we are looking at it this way, we want to use our rules. So it says that when you raise a power to a power, you raise each factor. That's how we got 4 to the third and f to the sixth to that, and you multiply. So taking each one to that power, we think of this as 3 to the first and x to the first. We're going to have 3 to the fourth power, x to the fourth, 3 to the fourth. We use our calculator possibly and get 81 as we are looking at that. So as we start this next one, we're going to do our work down below. We are going to start with, as I am looking at this one, Bashir, 7 to the what power? So 7 to the what power? Okay, so I have 7 to the first. What am I doing to get rid of this parenthesis? How many 7m to the 9th should I be writing out?
3.
So that means 7 to the what power? 3. And then m, we are taking this, and if you need to write down 9 times 3, or Bashir, I could put, okay, so 9 times 3, we could just do the multiplication. 9 times 3, which equals 27, okay? I am now going to take my calculator out, and let's do that, please, and take 7 to the third power. To the third power in our calculator, our answer in this case would be 343 m to the 27. Now this one starts to cause us like, oh, we got a negative exponent. So negative exponent, first thing I have to do, Rajad, when I have a negative exponent is what? Do the what's the word? It's like reciprocal. So we're going to rewrite this as, tell me what, 1 over 2g, and now it is to the fourth power. So now I have positive exponents. So Caitlin, as I'm going to do that, I'm going to have still 1 in my numerator, 2 to what power? 2 to the fourth, and g to what power? The fourth power. So leave out my calculator, I'm going to put in 2 to the fourth. Everyone else, put yours in your calculator, 2 to the fourth. So as we are looking at that, Levi, we're going to end up with? So 1/16, and then what? And g to the fourth. Okay. I want you to take a look at this. Sometimes I'll have some people solve this problem, and they don't like to take the reciprocal right away. Could you do it with 2 to the negative 4 and g to the negative 4? Yes. It's just that then your next step would be here. So does it matter if you take the reciprocal first or if you use power to a power? It doesn't matter. My hint is show your work. Most of the ones on the tests or on the quiz will be like a 3 or 4 point question. So in order for you to get your points, show what you're doing. I want to see how you're applying the rule. So if we're looking at this one, Sam, 6 is going to be to what power? 3. Then I'm going to put 8 to what power as I'm looking at it, Patrick? Third. And how about B? Also to the third, okay? Riley, as we're looking at that next one, we're going to put 5 to what power? 5 to the second. Then we're going to put our 3 as I'm looking at, or 8, Nolan, as I'm looking at it, to the, just sit down, you can do it later. Just write now. So Nolan, what would you have here when we multiply? -6. So as we are filling this in, we are going to rearrange our numbers. So 6 to the third times 5 to the second. Next, we are going to put all of our variables of a. So if I'm writing my a's, Matt, I'm going to have a to the what power? Third, and a to the -6. And then I have b to the third. Okay. I'm going to put this whole thing in my calculator. 6 to the third times 5 to the second. Okay? So you're taking 6 and you're raising it to the third power times, if you want to put in 25, or you could put in 5 squared, which does give us 5,400. So we have 5,400. So you will be able to use your calculators as you're looking at this. Next, we are adding our exponents. So Olivia, when we multiply with the same base, that 3 and negative 6, that's going to give us a to what power? Negative 3. And we only still have the b to the third. So as I'm finishing the problem, Joe, how am I going to write my final answer?
5,400 over a to the third.
Okay. Where's the b to the third going to be?
On top.
B to the third will also be on the top. So 5,400, b to the third. And again, if it helps you to think of circling what's going to move, the only thing that should be moving is the negative exponent, not negative numbers when you take a look at those. Okay? Questions at all?